Hi class, this is the video for section 5.1, an introduction to right triangle trigonometry. So for our first definition, a triangle in which one angle is a right angle is called a right triangle. So we can kind of picture it to look like this. These are supposed to be perpendicular to each other, exactly. So this is called a right triangle, and the side opposite of the right angle is called the hypotenuse. That's a special name for the longest side, and it's a right triangle because it contains a right angle. Okay, just to make sure like we know what an angle is, you have some kind of a fixed point, which is the vertex, and then you have a ray extending from that vertex. This is the initial side. So ordinarily it's drawn exactly in this position. And then we also have a terminal side. Okay, so another ray. And in between of them is an angle. So when we say an angle, that's what we mean. And a right angle looks exactly like what I've drawn. We often use Greek letters such as theta, alpha, beta, and gamma to denote angles. So for our next definition, if the rotation is counterclockwise, the angle is positive. And if the rotation is clockwise, the angle is negative. So for example, let's say that this is the initial side. So this angle here, alpha is a positive angle because that rotation is counterclockwise. And as another example, if this is our initial side, and let's say that we have this angle here, theta, going up until our terminal side, then this is clockwise, so theta is an example of a negative angle. So an angle can be positive or negative. Now, angles can be measured two different ways, degrees and radians. If you intend to take calculus, you will be using radians. But we can go back and forth interchangeably between these two units of measure using the following definition. Okay, first of all, the angle formed by rotating the initial side exactly once in the counterclockwise direction, this angle, one whole revolution is equal to 360 degrees. That's the full circle. So 1 degree, therefore, equals 1/360th of a revolution. And a right angle, which will be here, so this is the right angle, is 1/4 of a revolution. So 1/4 of 360 degrees equals 90 degrees. That's the right angle. So now we can practice using this definition to draw a variety of angles. So first angle we have is 60 degrees. So this means 60 over 3/60th of a revolution, which is, when you simplify 60 over 360, 1/6. So 1/6 of a full revolution. So this will be in the first quadrant. So here we have our initial side, and we know that this one here represents 90. So 60 will be right here. Okay, it's often useful to draw it in reference to 90, like 60 is 2/3 of the way to 90. Okay, and you'll notice that I drew it counterclockwise because it's positive. Compare that to part B, negative 120 degrees. Because it's negative, we know that it's going to be clockwise. So negative 120 over 360 is equal to negative 1/3. So it's going to be 1/3 of a revolution. This is more than 1/4, which is 90. So basically, this is our initial side. This is negative 90. We're going to go a little ways past that. So this is negative 120 degrees. Okay, so you can kind of think of it the way that I'm thinking of it is like negative 120 is negative 90 minus 30. So I went all the way to 90 and then just a third more of 90 past that. So that's what negative 120 degrees looks like. So then lastly, we have 540. So we're going to say that this is 1.5 revolutions. I can break it down as 360 plus 180. So we start with our initial side. We do a full 360, then we keep going until another 180. So this one will represent 540 degrees. So angles can in fact be greater than 360 degrees. It looks the same as 180, but it contains an additional full circle. Okay, so this is the degree measure. Now we're going to get radian measure through definition 4. So 1 radian equals 180 divided by pi, which is about 57 degrees. So 1 radian is much, much larger, about 57 times larger than 1 degree. And we have this fundamental equation that allows us to transform, which is that pi radians equals 180 degrees. Okay, so you can always keep this in mind. It's written here in a different format when you want to go back and forth. So for part 2A, well, for part 2 at all, we're going to convert to degrees and we're going to draw. So we have 4 pi over 3 radians. So we can put the radians there. And I want to change this into degrees. So I need to divide by radians and multiply by degrees. But I can only do this safely if what I multiply totally equals 1. So that's where I use this equation that 180 degrees equals pi radians. So when I multiply by 180 over pi, that's multiplying by 1. Radians cancel, pi cancels. So I have 4 times 180 over 3 degrees. In other words, 240 degrees. So we know that 4 pi over 3 is equal to 240 degrees. And we can also draw what this looks like, okay? So I'll just break it up a little bit. So 240 degrees, if you want to think of it in terms of degrees, it's 180 plus 60. It's right there. We could also graph it kind of like using radians to begin with, because 1 pi over 3 is going to be about that much, 2 pi over 3, 3 pi over 3, and then 4 pi over 3. So we can also just graph it directly in terms of radians. So I recommend you to get comfortable with radians and not always have to change back and forth to degrees. We're just changing these back and forth to practice using the conversion. Okay, so again, in part B, we have pi over 4 radians. So I already kind of know what this looks like because, oh, sorry, my Notability crashed again. This is a shame. So if it doesn't come up in a second, I'll pause the video and start it again, but hopefully I can revive it quite quickly. Okay, I'm just going to pause this.